Thank you, Ellie. So let me just start sharing my screen. Can you all see it? Good. Yeah, thank you for the introduction and thank you for inviting me. I think this initiative is really great. After having worked a couple of years in the tech sector, one thing you notice is that I was mostly surrounded by men. And so, yeah, it is also a great passion of mine to try to encourage other women to pursue a career in the field and not be intimidated by the fancy sounding words and things that are out there. So I don't know how familiar all of you are with the field of data science. I just want to set a little bit of context and give you a little introduction. This is all, of course, from my perspective. So you ask 10 other data scientists, you might get 10 other opinions, but this is just the way I see it. So to start off, the field of data or data science is quite diverse, actually. So once you start looking for jobs in the sector, maybe, you will, of course, see positions like data scientist, but you'll also see something like business intelligence. Then you'll see the data analyst, the data engineer or big data engineer, and words like deep learning, artificial intelligence, data warehouse, machine learning pop up. And this might, in the beginning, leave you a little bit confused, as it also did me. So I think my goal also a little bit with this today is to demystify some of these words for you and just kind of put them all in their right place and how they kind of interact together, what belongs together and what is sort of different from each other. So maybe if we take a step back and define it in very general terms, again, this is only my opinion, this is not a Wikipedia quote or anything. Data science in general, for me, is about finding patterns in data for a specific purpose. And this can be as simple as I'm extracting revenue from financial reports and plot it over time. And it can be as complicated as something like robots or self-driving cars. This is also data science from my perspective. I want to give you one very prominent example that is popping up all across the internet that you might know. That is a very, very classical application of data science, which is a recommender system. So what you see here is it's not actually my Netflix because I don't use it anymore. It's dangerous. I just took a screenshot from a Medium article. This is, most of you are familiar with this page. This is the home page when you visit your Netflix account. And the problem nowadays with a lot of things that are out there on the internet is that we have just so much information that it would be really hard if we would all need to screen every information that is out there. So Netflix, for example, I looked it up. I think Netflix US has like over 5,000 movies and TV shows and so on. So if we would decide after work, going through all of these 5,000 different offers, what we want to watch, we would go kind of crazy. So what Netflix in this case is doing, it is trying to recommend stuff that might be interesting for us to us. So in this case, you can basically see 3 different kinds of recommendations, varying in complexity or varying in how complicated and how targeted they are to you. Coming back to what I said before, what data science is about is finding patterns in data for a specific purpose. The purpose in this case being finding things that are relevant or interesting to a specific user. The data we would have in this case is Netflix is recording every single click, every single view, each and every one of us is doing on their website or on their app. This is our basis. And then we're trying to find patterns. So one pattern would be the thing that you see in the very bottom, or no, let's start with the middle, trending now. One pattern would be just to see what is popular right now in a specific region. So we would look at the number of views of specific series or movies. in a specific region. And we would come up with a list of the most popular things in the last, let's say, 24 hours. And we would say, hey, it's likely that a lot of people like it right now. So we're just going to recommend it to everyone who visits the page right now. This is a very general form of a recommendation. Another form, which you see in the bottom, it's equally a pattern in data, would be a topic-based recommendation. So in this case, let's say this guy obviously has watched Narcos. Narcos probably belongs to a certain category of TV shows, something around like mafia, crime, drug stuff. And it is probably a very specific category. So it makes sense that this user might also be interested in other things from that category. So pretty simple. You just give him a list of other stuff in that category. The most complicated one probably to generate is the top one here, the top picks. In that case, we're also again trying to find patterns, but we're looking a bit more specific at individual users. So usually what recommender systems do is they cluster users together, and they would try to pair this guy Joshua with other users that have a very similar viewing history. And then we would say, hey, this other person, Joshua too, has watched very similar things and was also interested in New Girl, apparently, and Breaking Bad. So let's give him that. So this is just kind of a, one specific example of how, of how recommender systems can work. It can get very, very complicated, can be very simple, but again, it's all about finding a pattern in data. And the example that I picked here, I picked because it is happening all across the internet nowadays. So every time you look for something, you type something in Google or another search engine, the results you get are ordered and filtered by what the algorithm thinks is interesting to you. When you go to any website, you might have noticed that if you looked at, I don't know, shoes before, then suddenly you get a bunch of ads around shoes. This is all kind of the same logic, that stuff is not being shown to you randomly and not all of the information, but a very specific subset. And this is a very, very classical example of data science we see nowadays. Of course, there's, as I said before, it's such a vast field, and it can, of course, get even more interesting, like self-driving cars. Super crazy that we can even do that. So how do you build something like that? What do you need in order to be able to build a simple or rather complex recommender system like that? So let's move on to what skills does a data scientist need? The bad news is that you need a bunch of different skills, actually. Data science is still quite a new field. And me, like most of the other data scientists out there, don't have a training in specifically, like we haven't studied data science. It's nowadays possible, but it wasn't before. And usually I really like this Venn diagram. You can find it, this is kind of, I created my own version, but you can find variants of it everywhere. And it basically says that the data scientist, or the skills of a data scientist, lie at the intersection of tech. So you need to be able to program. I'll get into what is important in that area after this. You need to have some background in math or statistics if you want to do stuff like predictive modeling, the thing that I just said before. If you want to build complex models, then it's very it's of advantage to have a background in statistics or math. And then I think also very important is either you have expertise in the domain that you do your analysis in, or you're able to communicate very well with people that do have this expertise, so that you're able to extract relevant information, because context is always important. So coming back to the Netflix recommender system example, you definitely need to know a little bit about how does an app like this work? How does Netflix in particular work? What are the business goals? You always need some sort of context. And as I said, most of the times you probably don't have the expertise yet, but you need to be able to extract it from people, from stakeholders that want something from you. So this is also very important. Now, about the various different positions available in the field of data science, I want to try to position them a little bit in this spectrum of skills. Everything around machine learning, artificial intelligence, or also deep learning, it's a very fancy expression, is basically, for me, or I think for most people, they would consider it a part of the data science. And usually the difference is that in machine learning, you write an algorithm or a program that learns itself. So you don't give it so much structure yourself. You let the computer learn by feeding it more data. An example, if we go back to, let me just go back to the Netflix screenshot. An example would be let's say Netflix, they probably have a recommender system like that. Every time, let's say Joshua decides to watch Breaking Bad, this is a feedback for the algorithm. And it's basically changing the underlying data we have used to create the model itself. So it's creating this sort of feedback loop. Every time you do something, it's information that that the algorithm has done well or hasn't done so well in predicting what you might like. Yeah. So this is how I would differentiate that. But still, it falls under the whole. It still falls under data science. Then also you can find a lot of positions like that. The data analyst or the business intelligence analyst. Business intelligence is basically a specific subfield, I would say, of data analysis that requires a lot of business knowledge, actually, how marketing works and stuff like that. But in a way, you don't need as many programming skills when you're a data analyst. Mostly you will use SQL, maybe some Python, but usually, you usually don't automate your analyses. So I want to again come back to that example. A data analytics example of this would be that we say, hey, we have this data, we take a screenshot, a snapshot of whatever has happened on Netflix up until now. I get that data set and I'm just trying to find patterns. And in the end, my result would, for example, be there's different clusters of users. I have found 10 different clusters of users, those that like, more TV shows and more action stuff, and then the movie people and so on. This would be an example of data analysis, but usually it lacks automation. So whenever you have something, an algorithm like this, that is producing data, that is producing results all the time and is part of your product, it is not, I wouldn't call this an analysis anymore. I would really call it an algorithm. And this is where stuff really becomes data science-y. I hope this was understandable. And then last field, we're still not at the very intersection. We're now rather we're leaving out the statistics part. But we need substantial IT skills, and we also need the domain expertise and communication that we talked about. And there I would place this is rather an old school term, the data warehouse architect. Nowadays, this is more called the data engineer or the big data engineer. And what these people do is basically, build up a data infrastructure so that everything, in Netflix's example, that everything that is happening is kind of processed and saved in real time at the right place, so that you can pick it, that the data scientists can pick it up from there and build models. So also a related discipline Oftentimes you'll have to do it yourself because there's no one to do it for you. But sometimes if you have a specialist, then you can, as a data scientist, really concentrate on building the models, and you'll have the whole infrastructure supplied to you. This is the ideal world. Okay, so because we're at Fearless into Tech, I want to focus a little bit on the IT skills you need as a data scientist. And I think this is in general a really good place to start. I don't think you need to study statistics for 4 years like I did. There's many great online resources nowadays, and you can really kind of build or do targeted courses towards specific models, depending on what your application is and what you want to do. But as for IT skills, there's a very basic toolkit or basic stack that you will need if you want to pursue a career in that field. First of all, SQL. This is like the most popular query language still, which is used to extract data from databases or data sources. Then Python, also quite important. There's also R, but I would really recommend to do Python because it also doesn't limit you. If you learn that, it doesn't limit you to the field of data. With Python, you can do all sorts of things. Yeah, so I would really recommend Python. And there's two libraries that I would recommend to look at. One is Pandas. This is kind of the data wrangling library. And then you have sklearn, which is like one of the most standard kind of machine learning library that allows you to build models very easily and very quickly. And there's great tutorials and blogs out there. And then you should know some basics about database management systems. So you probably want to start with something like PostgreSQL. So just how, for example, relational databases, how they work and how you extract data from there, but also what non-relational databases are. Because this is the pool of, this is where you get your knowledge from. So you should somehow know how information is structured. And a very good place that I always recommend to people is Kaggle. I'm not sure, maybe some of you heard of this website. Kaggle used to be a platform for sort of real life data science competitions, where I think sometimes it's companies that pose kind of a challenge with some real life data. And then it's usually about predicting something. And in the end, the person that has delivered the most accurate prediction will win the competition. But Kaggle, and I really like that approach also for learning, because it brings you away from this, like, I have a mini data set and I'm just going to do some lines of code, but gets you into the real life struggles that you have with data. But what I also really like about it is that they have free mini online courses. They're quite fun, and they really kind of everything I just mentioned, you can learn there. And I think it's quite nicely structured and always has this practical kind of element, which I think is more important than learning theory. And I think that is all I have to say. And I'm very curious to hear what you're curious about.
Thank you, Denise. This was really, really interesting, but it sort of also shows, at least shows me, how complex the whole area of data science is. I think we promoted this event also, you know, with the sentence that there are like as many pieces of data out there as there are stars in the universe. Is this something that you think sounds realistic? What would you say? Because from your example of the Netflix thing, we are permanently feeding information into a lot of different systems. So every day when I open an application when I use the internet, it doesn't matter what kind of interaction I am having. I might want to shop something, and I am constantly asked to deliver some information about myself to to buy or to sign up to anything. Um, what do I have to imagine happens afterwards as a user? Because most of us, we just do it, we don't really think so much about it, and then it's out there in the universe as the stars are, and we have no idea what's happening afterwards. So I have to imagine you as a data scientist on the other side. What are you doing with my data, Denise?
That really depends. That really depends. I I must say that I'm also kind of critical of my own field. I think it's a very exciting field, but I also see that most of the jobs out there are towards, for example, towards optimizing ad placement. So it's basically about finding out what you like, but not to make life easy for you, but to extract profit from you. So this is most of the things that are happening with your data, actually. So me personally, I don't do so much with it. I mean, I work for a meditation company right now, and we also do the usual, like, Facebook ads and whatnot. And my job there is basically to evaluate what works best. The way I tell myself, working for something that I think is very valuable to people, I tell myself that, it's nice to get the topic out there and to be able to spread the topic. And it's just kind of a game that you have to play nowadays in order to make yourself visible on the internet.
Right.
I'm not sure if
But
that answers your question.
no, it sort of does, but it also places another question, right? And I think we then go into this loop. I think you partly also answered one of the first questions here in the chat, which was to that they would like to know about your, how your day to day looks like concretely, and you sort of already started on that track, but being critical of what you do, I think it should be a part of every sort of job in a way. But what would you say are, like, for you, the best parts of data science? What are good things that you can do with your knowledge, and versus what are things that could do a lot of damage with your knowledge, and being somebody who's in charge of so much data?
Hmm. Okay, so I'm going to start with day to day, because I think maybe it's also somehow related. So day to day is, I mean, it is computer work. So you'll spend most of your day in front of a computer. That's the one thing. Most of my days are really just writing code. That's the most, yeah, I would say that's like 80% of the time. And then the rest is communicating with people and trying to find out what they actually want, and kind of be a translator from someone has a vague idea of what they would like to achieve, and you need to translate it into very specific action terms for yourself. So you need to be able to make this like this broad idea into code, and ultimately into an algorithm, for example. And then in the end, you also want to communicate back and tell them what you did, which isn't always that easy, because you go into your world, and in the end, telling someone that has absolutely nothing to do with this topic, then kind of breaking it down and trying to try to somehow explain what you did and what your problems were, isn't always so easy, but it's also fun. And then coming to your other question is, what good can you do with data science? So I must say, should I, by the way, stop my screen sharing now? I can stop it, right?
Yeah, you can do that. Sure.
Um, so for me personally, I started studying statistics because I always wanted to go into research, because I always believed that kind of reading data is the best thing we can do when it comes to quantitative or somehow modeling approach, because I came from my field before was economics, and there it was kind of having these theories and trying to build reality based on a bunch of theories. And I kind of liked it the other way around, to just be able to read from what's actually there and finding patterns in data. However, even there, I must say that I do believe in the power of that, but I also believe in its limits. I don't think that numbers is everything we should care about. And this is something that worries me a little bit nowadays. Everyone wants to become data driven, meaning that in the end, if you really bring it to an extreme, this means that people will just crunch numbers and look at numbers and do what is optimal, just based on a number. But sometimes the right thing to do might be the exact opposite. Or if you want to walk new paths, then you can't just do the thing that people are used to and that people are already susceptible to. You maybe want to, yeah, you want to shape something new. So this is something I'm very critical about. Still, I think that it is it it gives us an idea about how things really are. And it doesn't mean that we have to do it that way all the time, but it's still important to have that information. And also when it comes to business and marketing and all of that, I think it's an important snapshot um, of what's really happening. And I mean, there's so many great examples of data science, like, I don't know, disease prediction, like everything to do with image recognition is super interesting, or kind of all of the translation machines that we have. I think all of this is really great and um, can potentially make things better, but it can also potentially be a big threat. It's powerful.
Yeah. I mean, you just mentioned image recognition, right? Like I think most of us have already heard about face recognition things as well. Um, and I have a very good question here in the chat that directly speaks to these kind of things as well, because it refers to the gender biases that you might have in algorithms. What is your opinion in this regard? Is this something that you can measure? But we know that it is not only the gender biases that you encounter in algorithms. If you go back to the example of the face recognition, there are also some critical voices raising, because it is a fact that these algorithms can discriminate according to your to your background and to your ethnicity, right?
Yeah, definitely. I mean, an algorithm, first of all, it's only as good as the underlying data is, and some things you can't measure. So some things are are underneath, some factors are underneath observable factors that you will never be able to measure. And an algorithm cannot take this into account. And also an algorithm doesn't have a morale or something like this. So it will just very brutally take the data that you have and find correlations that you have. And it might as well be that it's sexist and racist and all of it. You can't, like, I'm not an expert in that field, but I wouldn't know how to make an algorithm not do that. I would rather say it's still us that need to do something with the results, or that need to interpret the numbers that we get in an intelligent way, and still use what we as humans can do, which is
Yeah.
yeah, have
but
judgment.
but do you think it would help if the persons who are writing the algorithms, who are reading the data, handling the data, if they are from different backgrounds?
Oh, definitely. Yeah. I think in general, when it comes to, I mean, tech nowadays, it doesn't only apply to data science, but to, I think, all fields. And it is used to make our lives easier and to solve a lot of the problems that we see. And I think that's great. But the thing is that every one of us, depending on how we grew up and how we were socialized, we're seeing a different world and we're seeing different problems in the world. So if you only let like a fraction of the people from a very specific socioeconomic background, let's say, develop these solutions and for the problems they are seeing, it will be very, what's einseitig in English?
Like
Uh,
unilateral, maybe,
yeah,
like one dimensional, you know.
yeah, not really
Okay, yeah,
balanced. Yeah,
yeah,
yeah.
yeah.
So that's why I think it's absolutely crucial, because it's really shaping our world more and more. So we need to be more and more diverse in kind of creating these technologies.
Yeah, absolutely. I mean, even when you presented yourself, right, and we started the session, you also sort of mentioned that the sector is pretty much male dominated, but you yourself still went for this specific career. You still, you know, chose to uh, teach yourself to program, to start learning Python, and to pursue this type of career. Did this knowledge of the sector being male dominated somehow influence your decision? And how does it influence you now, you know, and do you see any changes from when you started to compared to now where you are now, if something has changed in that regard? What was your trajectory basically?
Hmm. I think I didn't really, I want to say that it didn't play that much of a role. I just kind of followed what I thought was kind of where where I was good at, and also what sort of made sense in this world. Because I also, I wanted to in the end have skills that are wanted on the labor market. That's how I was raised. So that's what I did.
Yeah.
But I was also always I always liked math, and I always liked solving logical problems. And this is what this job is giving you. So
Mhm.
if you're into that, it's a great job. The thing about being often the only woman in the room, that and the struggles of that, I only realized when I started working in the field. And I think in terms of what changed until now, I mean, this was, I think, 5 years ago that I started. And maybe it was because I wasn't specifically looking for this information, or maybe because it was just not so much of a topic of public interest. But I do feel that nowadays we speak more about the issues that women often have at workplaces, and the thing of not being taken so seriously, and what do you do, and stuff like that. And whose fault is it? That was, in the beginning, it was really hard to kind of find a way to make yourself heard without being like a man. That's what I always wanted to avoid in that sense, like to not be the thing that or not kind of taking over some of the qualities that I just uh, found difficult sometimes. Um, and so I do see things changing. I also see maybe also I think there's also more women nowadays working in the field. And what is super important, and I think this is why you're doing such a great job, is building networks and talking to other women that are in similar situations, or just in general people um, that feel in a similar way, that are maybe a little bit fed up with the way we've been working for the past 50 years, and try to break them
Yeah.
up a little bit. Yeah.
In retrospect, it can be easier to see things in a different way. Like you say, sometimes we're not aware of what we're running into. And only when we start doing something, we encounter different challenges. If you could say like something to your male colleagues from back then, you know, what would you have told them to make your life easier? What would you tell male colleagues, for female colleagues everywhere who are in this sector and who are minorities in the sector, um, what could you tell them to make the the workplace a little bit more inclusive or more friendly towards female in the sector?
So I think the thing that I kind of found most difficult and still sometimes do in this field is that people are really trying hard to sound really smart. And this means that oftentimes things that are not that complicated are expressed in a very complicated way. And kind of
Yes.
and the bad thing is that I kind of regret sometimes is that I stepped into that same thing and I did the exact same thing. So what I would recommend everyone to do is the thing that you want to see in others, which would be more open about the stupid questions that you have, be more open if you're struggling, if you're stressed, if you don't understand something, if you need help. Just do it yourself, even if no one around you does it, because it will influence the group dynamics. And it will at some point also lead to the fact that other people will speak more openly about about what they don't know yet. And just add, like, for me the classical thing was in the first week when I started working, I had this little notebook and I was writing down all of the different things people were saying. I was like, what is a staging environment? I was like writing down everything and just googling it secretly in
Yeah.
my little my desk instead of just asking, you know.
Yeah.
And sometimes it's funny that after a while, when you start asking stuff and you specifically start asking abbreviations, it's a
Yes.
very
Oh
popular thing
yes.
in tech. You
Yeah.
realize that people actually don't know what they're saying. Like they, a lot of the times, not always, but a
Yeah.
lot of the times they're like, oh, I actually don't really know what this means. And then you start realizing that everyone is basically clueless in a lot of ways. Of course, there's experts in specific fields, but you can't know everything. And
Yeah.
especially with tech, it's such a rapidly moving sector that
Yeah.
I think you always somehow have to stay humble and not afraid to sound stupid.
Yeah. No, I
Yeah.
absolutely can relate to that because I also work in the sector, right? I also have a sort of a tech job, not as programming heavy as yours, but definitely tech heavy. And I saw exactly the same thing, so many abbreviations, so many stuff that can be super
Yeah.
complicated, and I've been asking and asking. But it can be sometimes hard to do that initial step. So I really find it very helpful that to hear that this is something that is not an individual case, but it is something that we are facing in different levels in different sectors, right? And I have a lot of persons who are asking a lot of things here, in regards to your motivation, your day to day, etc. But also, we have people who have started exploring the different paths. We have a direct question regarding the stack that you use at your daily work. Is that something you can maybe quickly answer to? What
Can
tech
you
stack
repeat
do you
that?
use? What
Our
tech
tech stack.
stack do you use?
Yeah.
Yeah.
Yeah. So at the moment, I work with Python. I work with Spark, which is like a big data processing tool, kind of. I work with Druid, which is a database system, and Kafka, which is also a data event storage. This is kind of the main things I work with at the moment. And before, I've also worked with Python, and I've also worked, I think, 1.5 years very intensively with R. This was in my first job.
Yeah.
Yeah.
And also, regarding your initial the initial slide that you showed with the different types of data science, whatever. There is a question regarding how is computer science related to data science?
I think more and more because just because the amount of data, we talked about this, the amount of data that we save and that we have is just increasing exponentially. And with the amount of data becoming bigger and bigger, the challenge to process this data quickly and to store this data efficiently is becoming more of an issue. And this is also something that nowadays you as a data scientist will need to write. You will need to write your algorithms in a very efficient manner so that it can handle all of that. And I think, I don't know, 4 years ago when the field was very young and we didn't have that much data, it wasn't so much of an issue. And it is related in, I think, a lot of the way. I think many data scientists come from computer science. So they do some maybe statistics or statistical modeling courses. And then you're basically good to go when you know how to write Python, when you know how databases work and how to work with data. We can definitely do it as a computer science person.
Wow, so that actually builds up on the next question, because I have a question here of somebody who says, considering about taking a bachelor in data science with a track in ML and AI. So abbreviation, I don't understand ML.
Machine learning.
Thank you. There we go.
Good that you ask.
and yeah. Yes, and AI maybe as well.
Artificial intelligence.
Artificial intelligence, right? So, but I don't know what level you need to reach before you really work with machine learning and artificial intelligence nowadays. So, how is generally the job prospect for bachelors in data science is the question. Can you say something about that?
Well, it depends on who's hiring. I'm not an expert in hiring. I have hired a couple of people myself, and I know that I don't really go for people that know everything. But for me, it's important that you have done something and you have done it right and you have some sort of record for it. So if you're a computer science bachelor, or whatever you have as a bachelor, and you start, for example, participating in Kaggle competitions, you're doing a lot of online courses, you have maybe your own project. There's so much public data available nowadays. If you have a good idea, just do it and put it on GitHub. And once it is on GitHub, GitHub is like your portfolio. If you have a portfolio and people can check it out and they can see that you do good work, I would say it's totally possible to get a job like that. And as for like this whole field is, I also still find it intimidating sometimes, because it all sounds very complicated. But the truth is, yes, you need some, I think it is very helpful to have some basics and to be really good at kind of logical thinking. But I participated, I think it was a couple of years ago, I participated in a hackathon, or a datathon it was called. So you have 2 days and you have a data set and you have a problem and you're supposed to solve it alone or in groups. And it was really interesting to see there were people that were so advanced in the field. But if you are confronted with a problem and a data set, you always start from scratch somehow. Of course, you build on your experience, but you always have to get really deep into it. It's nothing that comes super fast. You need time to understand the whole problem. And I would say anyone can do it if you're patient enough to start small and build up on what you've learned before. But machine learning in general, you can build a small machine learning project, and then from there you do something maybe a little fancier, and you just kind of progress slowly. Maybe don't try to, I don't know, build robots at Google with your first job. I don't know. Start small.
Yeah. But there is another career related question here. I think it's almost the same. It says, that a person was thinking about taking bachelor in computer science and learn
No,
Java.
sorry,
And
can you hear me?
yes, we can hear
Yes.
Sorry.
you.
Okay.
You can. You
I thought
want.
I was like constantly muted, or the conference just muted because I did because I have to like interrupt because this me that like writing these two parts and I was the first one is my question and the second one
Oh,
is basically answered my question because I was also thinking like taking a computer science bachelor and there's more like a I don't know because you got like different programming languages and for data science it's mostly like R Python, but there are also like object oriented programming languages. And so I've also tried that before, but I just turned out to find that I'm more interested in statistics and yeah, like generally, and just like Denise just said, because this whole field is pretty fancy and it's just pretty sometimes a little bit intimidating sometimes. So I was just thinking like maybe like doing a bachelor maybe not enough for you to really get into the job market. Like if you are just a bachelor and now they are hiring something like AI engineer. So this is something like I would like a little bit intimidated by, but you just give a really good advice about doing your little own projects and things. And thank you, a lot. Thank you.
yeah, thank you
Thanks.
for this. Um, I think, yeah, I think it's always like, I'm not sure if a computer science degree it will give you some basics, but I would always say that practice is much better. And so I know that there are specific degrees for data science nowadays. You might want to check that out. Or there's on websites like Coursera, you can do specializations in data science as well. Maybe do a combination of both. And I would say always just follow your interest. Like if you're right now interested in statistical modeling, go study statistics. Great. I can really recommend it. And do some programming on the side. If you're interested in computer science, do that. I think in the end, if you follow your interest, you will end up in the right place.
Yeah, and they are also asking if age matters when you want to join the field.
Mm, I don't know. I have no idea. I would say no. Um, I would say it's always possible to start, no matter how old or young you are. But I have no experience. If I don't know, do you
Yeah.
mean that maybe I have a maybe that person can specify? You mean that in a discrimination way? Like, are people not hired that are too young or too old, or
And
maybe you
could you
can?
elaborate, yes, sir? Because I don't know if we can get some more insight on that. But going back to the advice for people who don't necessarily follow the the traditional path into certain careers, right? Like you say, maybe data science, when you showed your presentation, you also said the bad news is that you do need a little bit more of knowledge of programming and languages and stuff. But the good news would be that nowadays everybody has access to a lot of resources, like you just mentioned, Coursera and all these extremely open source accessible libraries for everybody to out there to use, basically. But in my opinion, and this is also from my experience, because I also started learning to program, and that is basically what initiated the whole project with Fearless into Tech. For me, it was overwhelming, the amount of information that was out there, meaning all these courses and programs and all of that. There was so much of it, and I had no background and no knowledge and of these fancy words and all the terminology. So I just didn't know where to start. So from your experience, because you also started learning to program on your own, what would you recommend as a very first step to, sort of orientate yourself, to find a little bit of a way of finding your way around
Mhm.
all this information out there, all those resources. What would be, you know, something that you would say you could start with if you want to follow the career path you follow?
So I must say that when it comes to anything programming related, I'm not so much of a course person. Like I started with a couple of courses, I never finished any of them. The way I learned is I had so some of it I already learned at university, and I was just picking, let's say, for a seminar and for like an analysis I had to do. I was just kind of interested in how to make that code better, or just interested what's behind it. So I always had an application and something that I wanted to solve. And I think this way you learn the quickest, because even if you do a course, in the end, I always say, and it sounds funny, but it is true, the thing that you will do the most, even if you're yeah, a professional data scientist or a professional programmer, you will Google a lot. You will
Yes.
Google all the time. So I don't know how many times a day I just Google stuff that I Googled this 10 times before, but I just forgot. And then you go to Stack Overflow and you find someone that had the same issue, and you and you
Yeah.
just copy paste the solution or adapt it to your own needs. So this is really and I think no matter how many courses you took, this will always be, you will always lack some specific thing for the specific problem you're solving. So I think, again, think of your own little projects, maybe even in small groups. It's nice to motivate yourself. And I think a network like this is great to think of some projects, smaller projects like this. I found it super interesting at the beginning of this whole COVID pandemic thing, that there were so many live dashboards popping up and people that were just kind of taking the data and like just doing crazy stuff with it. And this is a great example of, there's any type of Twitter, whatever, they all have public APIs that you can get data from, and anything you think could be worth or interesting to look at, you can just do it. And
Yeah.
this way, of course, it might be hard in the beginning and frustrating because it takes a long time to get stuff to work. But at least that's my experience from the way I learned these things. Is it's good to have a practical example to kind of to really learn and really
To
advance.
relate to that, and then
Yeah. And I think for the whole field of data science, as I mentioned before, I think Kaggle is a great starting point, because it really it the way I haven't done these courses myself, but colleagues of mine have, and they're really great. They're they're kind of mini courses, so it doesn't take you like a half a year to finish something. So you get quick results, and it's very practical, and it's really everything around it. It has all the resources around data science, so you don't need to be super confused with all the different courses out there. But I would really recommend to check this out.
yeah, that's great. I have a comment, you know, building up on that age question. It says that it's because the elder you are, the slower you get to catch up with the field eventually. What is your opinion on that?
I don't know. I mean, I'm only 31, so I don't know if it's really true that you get slower with the older you are. I wouldn't say so. I think if there's motivation, and if you have a little bit, I think it's all also time. It's time and motivation, probably. If you can really dedicate some time to learning, do that regularly, then I don't think that that age is a factor there, I would say. But I don't know, ask me in 20 years.
Well,
And
I think well, I am 10 years older than you almost, or yeah, almost. I'm 9 years older than you, and I just started programming year ago, or learning to program, because I wouldn't say that I am a programmer now and that I can program. Not at all. I have like super basic HTML knowledge and you know, a little bit of JavaScript. That's it. And I use that for my computer science job, which has a lot of it's about cloud applications, whatever. But in my experience, I don't think it is the age. I think it is how you place yourself with all these things. So I think, you know, to all the good advice that you had given, the tools and the ways to start, the motivation, I think it also helps to have to find a community, to find people like learning buddies, to find people who are also, you know, going through the same or similar experience like yourself, connecting to those people. Don't also, you know, the same way that you should be shy of asking questions when you're at work, when you don't understand something, also become more bold about reaching out to people using tools like LinkedIn to connect with people who are in that sector, who are already working there. Just reaching out and saying hi. You will be surprised how positive the answers are that you get. If you ask nicely, you present yourself and your situation, you will be surprised how many people are willing to help you, to guide you through to your experience. So I think it doesn't necessarily has to do with age at all, but more, you know, about the, first of all, your motivation, but also the support that you get from other sides and how you learn to help yourself as well and ask for that support. So
yeah,
yeah,
definitely. Yeah,
but
that's very
it's
nice.
been an extremely interesting session. We run out of time without noticing. It's crazy.
True.
Yeah, it's really crazy. All I have to say for last words is I'm very, very happy that we had you, Denise. Thank you so much for your time, for donating your time to us, to helping us navigate this very complicated sector. We have recorded this session. We will upload it to YouTube, to our channel. We have shared the links here in the chat. You can follow us on LinkedIn and YouTube and Facebook. We have a page and a group. You're most welcome to join us, all of you. And yes, stay in touch, because we're organizing these sessions once a week to present different areas from the tech sector and the different careers and experiences. Thank you so much, and see you next time.